In this video, we're going to talk about section 6.6, which is using all the factoring that we've been talking about in the past and applying it to solving equations. Without this that we're talking about in this video, factoring is just factoring. Why the heck are we doing this? This will allow us to solve equations that otherwise we wouldn't be able to solve. So let's get started. We are going to solve what's called a quadratic. This is supposed to be a U. Equations using factoring. Okay, now we know what factoring is, but before we get into actually doing this, we need to know what the heck a quadratic equation is. So a quadratic equation is an equation in the form ax squared plus bx plus c equals 0. Now, a, b, and c are going to be numerical coefficients or constants, okay? But what's key here is a cannot equal 0. Okay, now what does that tell you? Only a cannot be equal to 0. Okay, c, that can be 0. B can be 0, but this cannot. So what makes a quadratic an actual quadratic is the existence of this x squared term. Okay, and that's where we're going to be using factoring to break that thing down into a solvable, regular variable and equation that we've seen in the past. Okay, now, before we can get into the factoring, there's one more thing that we have to know, which is the 0. I believe they call it the 0 factor property. In this textbook, I've also heard that called the 0 product property. Okay, same message, just a different name. Now, what this is saying is, if a times b equals 0, you have two things, or 3 or 4 things, but you have a product equaling 0, then a equals 0 or b equals 0. So if you have things being multiplied and they give you a 0 at the end, you need to have been multiplying by a 0 in the first place. Okay? You can't get a 0 with negatives or positive. They have to have a 0 somewhere in there. And that's this, along with the factoring, will allow us to solve stuff like that. Okay? So first thing, let's say we have that. Okay. Now you might say, well, that doesn't look like that. What the heck? If we were to distribute this out, it would. We would have an x squared, then a 1x minus 3x is a negative 2x, and then we would have a negative 3. So it is a quadratic. It just doesn't look like this, what we call a standard form. Okay. However, what's good about this is, notice it's a product. So we have this times this equals 0. Well, the 0 factor property says that then this must be 0 or this must be 0. Okay, now we solve. So I can add the 3. Here I can subtract the 1. And there you have your answers. That's all there is to it. Okay, if you wanted to check this, you plug them in one at a time. If I plug a 3 in, 3 minus 3 is 0, 3 plus 1 is 4, but 0 times 4 is 0. If I plug a negative 1, negative 1 minus 3 is negative 4. Negative 1 plus 1 is 0. Negative 4 times 0 is 0. So both of those answers work. Let's look at another one. Now, this looks like more of a standard quadratic. Now, what's really important for these problems is that you have a 0 on one side, okay? You have the 0, but you don't have a product going on here. Now, remember, what is factoring? Factoring is writing something as a product. So this is where the factoring is going to come into play. I want to factor using guess and check this trinomial. Okay? Same as we were doing before. X squared is x and x. It's a negative 22, so I'm going to have opposite signs. And I'm going to have a negative 11 and a positive 2. Okay? Don't feel like you have to rush through it and be really fast with it. Take your time. Factoring is really where most of the work is for these problems. Okay? So I factored that using guess and check. Now, I have this times this equals 0. Therefore, this must equal 0, or this must equal 0. I can subtract the 2. I can add the 11. And there you have it. Now, what's tempting is when you want to check these, you plug it back in here. Don't do that, because if you factored that wrong, but you did this right, it's not going to look like you did anything wrong. If you want to check it, plug a negative 2 in here and here, calculate that out, make sure you get a 0. Then plug an 11 in here and here, calculate that out, make sure you get a 0. Okay? But always go to the original problem when you're checking. How about this? Okay, now notice what's different about this. We don't have a 0 on one side. We need to have that in order to be able to use the factoring to use that zero product property. Okay, so what I'm going to do first is add the 49 over. And now we have that. Okay. Now, we could use guess and check on this, but maybe this is a perfect square trinomial. So what I'm going to first do is take the square root. Take the square root. So far, so good. If I multiply that, I get a 14x times 2, that's your 28x. And we have our middle term. So this is a perfect square trinomial. That's a 2x minus 7. Remember, we take this, we square it, and that's equal to 0. Okay? We're not quite done, but that's the bulk of the work, is the factoring. That's nothing new. Now, once we have this factor, we can set that equal to 0. Notice, since it's squared, there's just 2 of them. You don't need to write that twice. You just say 2x minus 7 equals 0. I can add the 7. And then I can divide by 2. And there we go. Okay. Since this quantity was squared, we say that that is a repeated solution, or you could say that's a 0 of 7 halves with a multiplicity of 2. When you get into like a pre-calc or a calculus, you'll talk about the meaning behind all that. Right now, all you need to know is the answer is 7 over 2. Let's look at a couple more. How about this? Okay, now what's really good about this is we got a 0 on one side. We don't have to mess with that. But we still have to factor this. Now, don't forget, the very first thing always to look for is if there's a GCF. And in this case, there is. Now, they're all divisible by 2. What I would suggest you do is take out a negative 2. Because when there's a negative in front of this x squared, the guess and check becomes a lot more complicated. I really wouldn't suggest you do that. Take a negative out so that this leading term is positive. So I'm going to take out a negative 2. And we have that. Before you move on, redistribute. Negative 2x, negative 4x, positive 30. Okay, make sure you didn't make a mistake and then you're using wrong information. Next, let's try the guess and check. X squared is x and x. Negative 15 is going to require opposite signs. I have a positive 5 and a negative 3, and that'll give me that positive 2. Okay. Now, once it's factored, we have to set each of those factors equal to 0. Now, one thing I want to point out here, I have this as a factor, this, and this. Now, notice this constant GCF that I took out, negative 2 equals 0, that's never going to equal 0. So that just gets tossed. Now, if there was an x on that, and I had a negative 2x equals 0, that can be solved. Okay, but when it's just a numerical GCF, I can just toss it away. And then my answers are a negative 5 and a positive 3. Okay, and one more. Say that. Now, what I want to be very clear on with something like this, a lot of people want to look at that and they want to divide both sides by, let's say, 7x. The problem with that is you're going to be eliminating one of the x's when you do that. Please do not do that, okay? If you see an exponent here and you have an equation, get a 0 on one side. Just don't even think about it, get a 0 on one side. So I'm going to subtract 63x like so. Okay, next I'm going to factor. Notice there is a GCF between both of these, and that is 7x. And I got x squared minus 9 equals 0. Before we move on, 7x cubed, negative 63x. Good. Now this binomial, remember, is a difference of two squares. So I've got x plus 3, x minus 3. And now that is fully factored. Now, this is what I was talking about in that previous example. This doesn't just get tossed away. Because 7x equals 0, that is a solvable algebraic equation. So is this. So is this. Okay. Here, I would divide by 7, and I would just get a 0. Subtract 3. And add 3. And now I have 3 answers. Something I want to point out with this. Notice I have 3 answers here. That's different than the other examples. When we started this problem, it was an x cubed. That exponent of 3, 3 answers. Over here, we had an x squared. 2, 2 answers. So if you find yourself making a mistake with this sometimes, like sometimes you throw it out when you shouldn't or something like that, then look for the exponent in the problem to match the number of answers you have, okay? When we had that one before, where I can kind of see it here, when it was like that, and then we just had the one answer, and you might think, well, wait a minute, we just had one answer and there was an x squared. We didn't. We had one answer, one unique answer, but it was repeated. So there were still technically 2 answers, they just happened to be the same. Okay, so that exponent trick is very, very useful if you find yourself making the mistake of leaving out or adding solutions that should or should not be there. Okay, notice on this, guys, there's the bulk of the work. Like for instance, on this one, bulk of that work was factoring, nothing new. So please focus on the factoring. After that, it's very, very simple 1 or 2 step equations that we learned way, way back in the past. Okay, so take your time with the factoring, focus on that, and after that, piece of cake. Okay? So work hard. See you next time.